In this video, we will discuss correlation. Correlation is the measure of association that we use for interval level data. I will walk you through calculating a Pearson correlation coefficient using the following problem from your textbook. An education specialist is interested in how the number of words learned within the first 2 years of a child's life affects the trajectory of academic performance later in high school. Calculate a Pearson's correlation coefficient for the relationship between words known at age 2, x, and high school grade point average, or GPA, y. Find the strength and the direction of the relationship and evaluate the null hypothesis. So in this case, our x scores right over here represent the number of words learned within the first 2 years of life, and the y scores represent high school grade point average, or GPA. Correlation uses deviation scores, and so the first step is to find the means from which the scores will deviate. So I'll do that right now, where I have the word mean written down, equals, insert function. I'm going to select average. I'm going to average these scores, and we have a mean of 14 words known by age 2. So I'll do the same average over here for the y scores. And we end up with an average GPA of 3.24. The next step is to calculate the deviation scores. So I'll take this first x score of 20, and I will subtract the mean for x, which is 14. But because I'm going to want to subtract the mean from all of the x scores, I need to keep this second term constant. So I'm going to put a $sign before the b and a $sign before the 14, and that tells me every time I drag down this formula, it's always going to use the mean as the item to be subtracted. So the first deviation score is 6, and I can see very easily that 20 minus 14 equals 6, and I'm going to drag down to populate the rest of the cells. And I'll do the same for y, put an equal sign here, select the first score, minus the mean. But again, we have to put the $sign because I want Excel to always use the mean in this case. All right. And so we have a deviation of 0.28 for the first y score from the mean. I'll drag this down. All right. And as you learned before, deviation scores should sum to 0. And so I'm going to make sure that they do. I'm going to sum up the x deviations. Oh, thank goodness, it comes to 0, and I'll do the same for this. Yes, so our deviation scores, as they should, do sum to 0. So let's look at the formula for Pearson's correlation right over here. Let's see. Pearson's correlation coefficient, indicated by R, is equal to the product of the deviations divided by the square root of the squared deviations of x times the squared deviations of y. And here's the long form of the equation as well. And now that we have an idea of the numbers needed for the formula, let's start with the sum of the deviation products. So we have right here equals, I'm going to take the first deviation and multiply it by the y deviation. All right, and then I'm going to drag this down. Very good. And now we have the sum of the deviations multiplied. Okay. And the next step is to square the x deviation scores. So we have the x deviation here, easy enough, put equals, and I will square it, and I will drag down. And we have to do the same for the y deviation score. So I'll take the first y deviation score and square it. Oh my goodness, okay. And we go all the way down. We make it more beautiful by getting rid of the 16 decimal places. Okay. All right. And the last step here is to sum up the deviation products and the squared deviations. So easy enough, equals sum. Pull these guys down. I'll drag this over. And voila, we now have everything we need to calculate Pearson's correlation coefficient. So I'm going to look at this formula right here, and as you'll notice, it's the sum of the x deviations times the y deviation is the first part. So I will simply select that sum that we figured out. I'm going to put a division symbol. I'm going to put everything here in parentheses because I'm going to find the square root. So square root is first, in parentheses. And now we're looking for the sum of the x deviations times the sum of the y deviations. So that times that. And then I'm going to close the denominator, press return, and we end up with a Pearson's correlation of 0.91. Correlations vary between -1 and +1. The sign tells us whether we have a positive association or a negative association, and the magnitude tells us the strength of that correlation. And in this case, we have a very strong positive correlation, meaning that the more words known in age 2, the higher the GPA in school. And you could also say the fewer words known at age 2 is associated with a lower GPA in high school. Your textbook also provides a computational formula, so let's take a look at that. It's allegedly simpler, although I tend to prefer the deviation method. But for this formula to work, we need 3 different columns. We need x squared, y squared, and the product of x times y, and you can see that right here. That is what we need to use the formula for raw scores. So let's go ahead and fill these in, finding x squared first, x. All right, and I'm going to drag that down, and then I'm also going to find y squared. Okay, and finally we need the product of x times y, so x times y, and I'm going to go ahead and drag that down. Okay, and now the last thing we're going to do is sum up these individual columns, sum that one, and then I'm going to bring it over here. And now we have everything we need for the computational formula. So let's plug in our numbers, and you might want to do this in separate steps. I'm going to live on the edge and do it all at once. So I'm going to start with the equals, and I'm going to put the numerator in parentheses. And it asks for first the sum of x times y, easy, minus, and then it's asking for our n, so how many scores do we have? And in this case we have 6 scores, 6 times the mean of x, whoops. Okay, hold on just a second, I guess I did that. Okay, 6 times the mean of x times the mean of y. And I'm going to close the numerator so that we have everything contained in those parentheses. I'm going to use a division sign. And then I'm going to put the whole numerator in parentheses as well, square root. And now I have to put everything that comes after the square root in parentheses. Here we go. And I'm going to use a new parentheses because we have 2 different terms that we're going to be multiplying within the square root. And so the first thing it asks for is the sum of the x squared minus our n of 6 times the mean of x squared. Okay, I'm going to close that first parentheses, and then I'm going to multiply by the second set, which is the sum of the y squared minus our n of 6 times the mean of y squared. Now I have to close this second parenthesis. I have to close the multiplication term in the middle. Then I have to close the whole thing. See, did I get it all? We'll see. It'll tell me if I didn't. Oh, my goodness. Yes. And as you can see, our 0.91 is exactly equal to the 0.91 we found with the deviation method. And so there we are. We have the same correlation whether we use the raw score method, which we've just done, or the deviation method. Okay. The final step is to determine whether or not our value is significant. And your textbook provides a formula for determining this using the t-statistic. But your book also provides this in a table entitled Critical Values of R at the 0.05 and 0.01 levels of significance. Of course, consulting a table is much easier than calculating a t-statistic. So the only information we need for the table is the degrees of freedom. So for correlation, the degrees of freedom is equal to our n minus 2, where n is the number of pairs of scores, or in other words, the number of individuals that we have data on. In this example, our n is 6. So to calculate our degrees of freedom, which is 6 minus 2, and we have a degrees of freedom of 4. So right now what we're going to do is we're going to consult the table. And for me, it's table H in my 12th edition book, but your table might be different, different letter here, but it is entitled Critical Values of R at the 0.05 and 0.01 levels of significance. And next to it, in my book anyway, was the non-parametric table, but we're not looking at that one. So we have 4 degrees of freedom, and we want the 0.05 significance level. And so I look right here. For 4 degrees of freedom, the critical value is going to be 0.8114. So I'm going to add that in here. 0.8114. Okay, so I need to evaluate our observed correlation against the critical value, and I see that our observed correlation is higher than the critical value, and I'm going to reject the null hypothesis. So in review, we can say that there is a strong positive correlation between number of words known at H2 and high school GPA, and we can reject the null hypothesis that there is no correlation between these variables. So, easy enough? The Pearson correlation coefficient is something you will likely encounter in the future as a regular consumer of research, and so knowing how it is calculated puts you a step ahead of the crowd. And as always, I look forward to answering any questions you have on the discussion board.